Hey everyone, so today we're going to take notes on lesson 3.4, which is writing linear equations from real world situations. So sometimes they're called verbal descriptions. We need to identify important information within it. For instance, in slope-intercept form, we need to be able to find the rate of change, which is another word for slope, and the starting value, which is our y-intercept of the equation. I can write an equation in standard form if we're given two rates, so basically like two slopes and a total value. So let's see what that looks like in the equations. So here's the first one. We know m as slope, and we know b as the y-intercept. But in a real-world problem, they mean different things. For instance, slope, we think about, we look for words like per or each or every. And we also look for words that are rates of some kind. So I'm going to put the word rate on here as well. And the y-intercept is a starting value. Sometimes it's like a one-time fee that you have to pay rather than a rate. It's something that you pay only one time. So there are many different things they could be in the word problem. So now let's go ahead and look at what standard form is. Now standard form, the a and the b values, the numbers in front of the x and the y, don't mean anything normally, but in a real world situation, they mean two rates. So once again, we're looking for words like per, each, and every. So the c value is like the total. So if you're adding two things together, you can see the plus between the a and the b. We're adding two things together so we get some sort of total. Other words you might see are sum. And hopefully this will help you a lot. I would go back to this front page when you're doing practice so that you can look for certain words so you know how to write the equations. So go ahead and open up your notes and let's look at the first example. We got to look at some of those key things in the first example as well. So let's see. Each, that's important. Each case of paper costs $37.99. The company that sells the cases of paper charges a flat rate, ooh, that's important, flat rate shipping fee of $6.95. Okay, no matter the number of cases you purchase. Write the linear function that models the total cost T for a single order of C cases. So if we go back, we saw these words somewhere, each and flat rate. So go back up here, right there. One-time fee, okay, let's add that. Turns out we didn't have it on there to begin with, did we? So let's go up here and we're going to add flat rate. You're only paying it one time. Okay, and so flat rate, whatever the flat rate was for that shipping, is the y-intercept b. And then each case is the slope m. So we had also seen the word each in our word problem, which means slope. So let's go ahead and go back to that word problem right here. I wrote y equals mx plus b because if we have a flat rate and a rate per case, that means that we're going to use this equation. So y equals, our m slope is $37.99, and then our y-intercept is $6.95. Now we're going to use the letters that they told us to use. It says the total cost T for the number of C cases. So y is your total cost because you're adding these two things together and they're going to give you y, the total cost. So t, our final equation is t equals $37.99 per case, so we're using the letter C instead of X, plus the $6.95 shipping fee that you only pay once. Okay, let's read example number 2. Summer is over and the Sanchez family is sad that they can no longer use their pool during these cold months. The pool contains 10,800 gallons of water and must now be drained. That's pretty important. It started with this many gallons of water, but they're draining it. The pool drains at a rate of 150 gallons per hour. Okay? And so the function we're writing models how much water is remaining. So just like y and x, we have an f of x and x. We have w of t is like y equals, and then they start with this many gallons, 10,800, and it's draining, so minus 150 gallons per hour, which they use the letter T to represent hours. It says so right here. Okay, you could also switch them to look more like y equals mx plus b, where the negative 150t goes first. That's like mx plus the b value. So both of these are correct. Okay. Keep that in mind. A lot of people write it this way because it makes more sense to them. This is how much we started with, and we're draining at this rate, 150 gallons per hour, and T is the number of hours. So this was also slope-intercept form, y equals mx plus b. Now let's look at example 3. Quite an interesting example, number 3. Let's see, the total cost y for X hours of plumbing work includes a flat fee, oh that's important, a flat fee, as a cost for retaining their services and a cost per hour. So that means we're going to have a slope, m, and your flat fee is your b, your y-intercept. One customer paid 6 hours of work costing $217. And another customer paid 9 hours of work costing $313. Write a linear equation that represents the total cost in dollars y for X tickets. So we are using y equals mx plus b. So for this problem, they didn't give you the rate and they didn't give you the flat fee. What they gave you was two specific inputs and outputs. If they work 6 hours, they get this much money, $217. If they work 9 hours, they get this much money, $313. And so what we want to know is what is the slope and what is the y-intercept, so we can find out what is the rate they're getting paid per hour and what is that flat fee. So we can do it by hand, or we could use Desmos, just like y'all have been taught in the last couple days. So remember, in Desmos, to add a table, we hit the plus and then table. And then we're going to type in that little table we made. For 6 hours of work, they paid $217. And for 9 hours of work, it was $313. Y1 tilde symbol mx1 plus b. And you can see our m is 32 and our b is 25. M is 32 and B is 25. So what that means for this problem, and I'm going to write it down. This is the final answer, but let's remember what it means. This is the cost per hour. And this is the flat fee they were referring to. The reason that the 32 is the cost per hour is because X is the number of hours. You take 32 and you multiply it by X, the number of hours, and you'll get your cost. And then you add that flat fee that you pay one time onto it. Okay? All right, let's go over at the last two examples. All right, so now we're doing standard form problems. So Tracy is making a large batch of granola. Interesting. I don't even know how to make granola. She needs to buy walnuts and almonds. A lot of times when you see two things being compared, like walnuts and almonds, or large candles and small candles, or hot dogs and hamburgers, that usually means you're going to use standard form. So walnuts cost $3 per pound and almonds cost $2 per pound. So we have two rates. See how the word per is on there twice? That means that this is a standard form equation because there are two rates. I'm going to go ahead and write out the standard form equation. Okay, and C, remember, is the total cost. The total cost they spend is $30.25. So that is C. So let's go ahead and write our equation. It does not matter. You do need to look at a few things here because they do tell us that walnuts specifically represent X. So notice I highlighted it in the same color as walnuts up here in the second line because that means the $3 has to go with the X because it's $3 per pound of walnuts. So 3X. And then almonds are $2 and almonds are represented by the letter Y. So the 2 has to go with the Y. It does matter which number goes with which letter. And then the total cost of the granola is the C value. Okay. So I'm going to pause the video and I want you to try example 5 on your own. Pause it, please, and try 5 on your own. Try to write the equation using the letters provided in the word problem. Okay, everyone, so looking at this, instead of using X and Y, you can see that it tells us to use D and N, and it doesn't really matter which one you do first. So since D is first in the word problem, I'm going to use D, and I'm leaving spaces for the A and B values. And the total cost that the total amount of money they have in their jar is $78.25. But keep in mind, D stands for the number of dimes, and N stands for the number of nickels. So we have to add how much they cost, how much they're worth. Okay, dimes, and then you can see I made a little chart over here for you in case you've forgotten. Dimes are worth 10 cents. So it's 10 cents per dime. So the A value in the equation is 10 cents. And a nickel is 5 cents, so 0.05. So that is our equation. 10 cents per dime plus 5 cents per nickel equals a total of $78.25 in their jar. So if you ever come across money, you need to put how much that money is worth. It is important to know that. So after this, you should work on your assignment that the sub gives you. Okay, guys? Have a great day.